with the previous video discussing about the other excavation equipment, shovel, clamshells, drag lines, trenching technologies, including trenchless technology that you have. For this one, I go over one more production of excavation equipment, and in this case, the shovel. And as you can see in the previous presentation, for the bucket, it can be front dump or bottom dump. Can be front dump or bottom bucket. And normally for the shovel, it digging or excavating above the track level. Above track level. So the material that they excavate above what is the shovel standing. And there are two basics methods that you see in the previous presentation, that frontal approach and parallel approach. So you may refer to the slide and the presentation previously. So two basics method. Of digging. What are they? The first one is frontal. Approach. Basically, in this approach, the equipment move forward and excavate, and the truck go parallel to the excavation equipment. And the other one is parallel approach. So the excavation direction and the equipment direction are in parallel. Again, you can refer to the previous explanation. Parallel approach. And similarly, to find out the shovel productions for this one, so in terms of the shovel production, we can have the production similar to the backhoe, and measure in terms of load cubic yard per hour. It equal to C, cycle per hour, S, swing factor, time V, bucket volume, time B, bucket fill factor, time efficiency. And for the C, you can go to table 3.6. So we have C, it means the cycle per hour, same definition that we have here. C, go to table 3. 3.5, and then we have a swing factor S. Go to table 3.6, and I'm going to show you what is that table here. Shovel and the cycle, we can go to that table, same table. So you see 3.6 for both, and then adjustment swing factor. As you can see, when the swing angle is increased, the adjustment is going down, which means the less efficient. So from that, we need to improve production. Then we have to minimize the angle of swing, etc. So let me make a few notes in here. So both in table 5.6, both in table 5.6. And to improve production, how to improve production? From that table, implication for improve the production of the servo. What we can do, basically two things that we can do in here. The first is to minimize the angle of swing so that we can increase the cycle time, and reduce the cycle time, increase the cycles, number of cycles C. So minimum angle of swing. And we can move servo up frequently so that we can have more load applied to the material. Move servo up frequently. Okay, so those are the production for the servo, and let's apply quickly in problem 2 here. The servo with the 5 cubic yard heap capacity front bucket is loading poorly plastic rock, so that they give you a material. The whole unit can be positioned so the swing angles is only 60 degrees, so the angle of swing is small. That's good. What is the ideal production of in LCY per hour? So from that we can have the equation, right? Production of shovel, it equal to, with the equation here, C S V B E. And with that we can go to table 536. So you can find out what is C, which is the number of cycles. And we can go to that same table to find out what is the swing factor. And in this case, 5 cubic yard heap capacity and 60 degree. Keep that in mind when we do. And this is a poorly plastic rock. So let's go down to here. So poorly plastic rock, the last column. And our is 5 cubic yard. So you can have a front dump, right? So it will be 130 for C. And the adjustment factor, the angle is 60 degrees. So we have that SE 1.1. So that we can have C equal to 130 cycle per hour. S equal to 1.1. And then you also want to find out what is the bucket fill factor, and that go to table, if you recall very earlier, 3.2 for the polyplast material. Let's go down here. Bucket fill factor. You see bucket fill factor. Polyplastic is somewhere between 0.4 and 0.7. I get something in the middle. Let's say that the last column, last row in here, be 0.55. So you can have B here 0.55. So from that we can have the production equal to cycle, number of cycle 130, S swing factor 110, heap bucket volume 5 cubic yard, bucket fill factor for the polyplastic rock 0.55, efficiency, the ideal production, as you can see here. So we can have ideal production that the problem give us. So we can have that E equal to 1, right? So with ideal production. Ideal, so we have E equal to 1. So with that time gone, so from that we can have the answer 393 LCY loose cubic yard per hour, and that for the answer. And that we done for the excavation. In the next one we will talking about the lifting, which is dealing with the crane.